Let's take a look at one of the most popular heating controllers, or well, heating and cooling controllers on eBay. It's a module called the STC-1000, and it's notable for having two relays, one for the heater and one for either a fan or a compressor for cooling. The power supplies they can operate from are 12 volt, 24 volt, or 110 to 220 volt, presumably encompassing 240 volt as well. I actually recommend not going for the mains voltage ones. The circuitry inside is not usually that great, so I think it's going to be more reliable if you used an external power supply with it. Although having said that, they're so cheap, maybe just treat it as a disposable item. I also note that the relays in them, they say 10 amp at 220 volts AC. I'm not sure I'd really trust them at that because these are using these pokey little relays they tend to use. I'd only trust them for maybe about 1 or 2 amps with a resistive load. I wouldn't trust them with an inductive load because it can cause contact arcing. And if you use a 12 volt one and then bring it out to 12 volt relays, that is going to make things much more reliable. Depends how much money you want to spend, depends how sort of professional you want to be. Let's zoom down on this and I'll show you how to set various parameters in it. So at the moment, I wish I'd let this cool down a bit more to the point that it's on the borderline of actually bringing in the heating. Because at the moment, if I press the up arrow, it shows the temperature it's set to. And if I press the down arrow, it shows the differential. And I'll show you what those mean in a moment. At the moment, it's displaying 17. The heating is not on even though it's below 20 degrees Celsius because it's not reached that differential of 3 degrees. But as soon as this gets down to 17 degrees, then it will bring in the heater. It's not going to do that soon, is it? I'm just going to hold this in a pair of pliers to try and cool it down because the pliers are fairly cool, I think. This is going to be like watching paint dry. Oh, there it goes. It's gone down below 17. That's the 3 degree differential between your base temperature of 20 degrees Celsius. Oh, it is just Celsius, by the way. I took a look through a display. I couldn't see an F. So it is just Celsius. Likewise, when you get up to the temperature that you're aiming at, and I'll just heat this, which is in this case, it's 20 degrees. As soon as you get there, it will cut out. But if it goes beyond that, if it gets too hot, it adds that 3 degree differential again in the positive direction, the higher direction. And when it gets there, the cool LED has started flashing, but the relay hasn't come in. That's because it's designed for driving compressors and you don't want to cycle compressors on and off too much. So it started a time delay, which I've set for 1 minute. After 1 minute, the relay will click in. Let me show you how you set this. So I've already shown that you've got the up button to check the temperature you've got it set to. You've got the down button to check your differential above and below that temperature that the relays will kick in. If you press and hold S, it goes into the setting mode and there are only 4 settings. This is good. So if we go to F1 and we display it by pressing S, we can then adjust it by holding the S down and using the up-down buttons to adjust that temperature. So that's how you set the temperature that you're aiming for. So let's set it to 21. I don't know why they give it in tenths. It just seems a waste of time, really. The timer's timed out, the compressor started. So going back into setting mode again, because it comes out of setting very quickly. If we then go into F2, F2 is the differential, press it, it's displaying it's a 3 degrees differential, and then you can adjust that up and down as desired by tenths of a degree again. That is the position above and below your base temperature that stuff will kick in. The next 2 settings, F3 and 4, if I hold this to go into setting again, and we go up to F3 and set it, it's displaying 1. All you've got here are, well, I was going to say all you've got are 10 options. This is the time that the compressor will hold off. So that's 10 minutes, and it goes down to theoretically 1 minute, but something that's not documented. If you go down lower, if you go to 0, it just means there's no time delay. The compressor would start immediately. The other setting is for compensating the thermistor. Because there's a bit of variation between thermistors, what you do is you put this unit into your application with the thermistor in a sensible position to get a good ambient temperature in there. You put in a proper calibrated thermostat or temperature display, and you compare the two readings. And if this is, say, a couple of degrees lower, what you can do with this is you can go into the setting mode again. You can go into F4, which is currently displaying 0, and then by holding that down, you can then compensate for the accuracy of the thermistor. So by leaving it at 0, it's just basically as it comes, but you can nudge it in either direction. Other functions that might be useful, if you press and hold the power button, it turns the unit off, including all the relays. Press and hold it again, it comes back on again. It's useful to know that if you do press and hold it and turn it off, and then you kill power to the unit, which I've done right now, and then you power it back up again, it will turn back on by default, which is quite useful. So let's take it apart. Now, things worth noting. Because it uses pokey little relays in here, as you'll see in a moment, let me zoom out for this because I don't want to get too close. I actually recommend backing it up. If you've got a critical application, say you're heating water or something like that, and if this crashed, or if the relay welded shut, or if you're using a solid state relay to actually drive the final load and it failed short circuit, as they often do, it's really important to have an extra thermal cutout. This is a standard bimetallic switch, readily available online, and it's just simply, it's below the rated temperature, it's closed, but when it gets above the rated temperature, it opens. If you want an extra safety feature, put a neon indicator with a built-in resistor across this and put it in the panel with a little warning light again next to it. If it ever lights, it means this is actually cut in. It's unlikely in many instances unless you're using high loads, but it can happen. But what happens when this opens and goes open circuit, some of the current flows through the neon and makes it light, and you could put a message on saying, call the engineer now. Let's open this. So to mount it into position in the panel, you've got these little grips at the side, and when you push them down, it unlocks them. You take them off, you slide it through from the front of the panel, and then you slide these back on, and when you actually slide them up, it kind of clicks into position and locks into position. The back for wiring has these horrible little clips that you squeeze in, and they come out. They say horrible because these little grips, when you squeeze it, it cantilevers them and they only open a tiny little bit. It's actually, you're not pushing the clip in as such, you're actually levering it so it twists. I actually recommend just getting a file and just taking the edge off those a little bit. It'll make them much easier to get off later on. There is also the option in some of these to put a screw in to actually lock it into position. You'd have to be careful about that because it doesn't seem drilled or anything for it, but the functionality has been put in there. This label is actually presumably doubling up as a warranty label. We're going to have to break the warranty label. I'm going to slit this. I have slit it. And then to get it off, we pop a screwdriver in here and we just lift this little flap at the side and at the other side, and then the whole lot just slides out. What do we have? We've got a bridge rectifier, some wire links. Oh, this is designed to take the, if we take a closer look at this, it's designed to take the full main circuitry, including the switch mode power supply and the little switching chip. But in this case, they've just jumpered across that from the primary side to the secondary side. And they've got probably the first level of smoothing capacitor, or is that the second? And they've got a little regulator here, probably a 78L05, I'm going to guess. 78M05, medium-sized one. Other things I'm noticing here, I'll take a picture of this later on, just for a general reference. But I see a couple of transistors, pull-down resistors, or series resistors, and then I see the protection diodes. There's really not much to it. The thermistor, which comes in right in the middle of all that main circuitry. I wonder if that's going to be like another one. It seems to go up to this unit, and if you look at this display, you can see the circuitry tucked underneath it. It's very, very basic. It's like one little microcontroller doing everything, including driving the display. Let's peel that display cover off. I just don't like those being left on, but they usually do. That plastic film is put on during manufacture to stop all the resin flowing out the bottom, but it's left on as a protective layer. It can look a bit shiny and glarish. Oh, this one actually has a little microcontroller on the bottom, and I'm going to guess that it also uses that for a serial display driver for the driving the LED display. There's not really much in them, is there? The relays have solder beefed up tracks. It's actually got the position for a changeover contact, but only in one of them. That's a bit strange. It also has other contact positions, maybe for two sensors. I'm not really sure. It'll be a fairly universal design. Right, tell you what, let's take the mains voltage one apart. So once again, we've got, I'll try and keep these bits separate just in case they're not that standard. So once again, click down on this, click down on this. We don't really need to take the back off this one. We'll just pop the little catch up like that, pop the little catch up like that, and it should slide out. How does it compare? Very similar, but with the transformer in that. There's the little switch mode chip. Some of these pads are populated, and the switch mode circuitry is all around that temperature sensor. With the pads in very close vicinity, that's a bit creepy. That's not good design. Another thing worth noting, when you route the thermistor cables, keep them away from mains cables, they can pick up interference in the mains and it causes instability of the display. So this one is not coming out easily. It's got little clips at the side that I shall poke in. There it is. Once again, it's got that film that I dislike. Rip it off. Don't think it really matters that much, but I'm going to do it anyway because yeah, it's just got this C here. It's not designed to have the option of Fahrenheit at all. And this one, I don't know if this one is the same brand or not. We'll find out when I open it. It looks very similar, but it came from a different supplier and it came in different packaging. Once again, I'm going to have to slit the label here. Oh, very badly slit. Oh, blimey, I really didn't slit that well. Not to worry. It went all over the place. Clumsy. I shall just use brute force then. Ugh. Different. But not that different. Is it a standard circuit board? Is it different companies? One capacitor missing, the cheapskates. But more or less the same, although they've got more components down here. And the circuit board, this one has the chips in the back. This one does not. This one will have that thing that the chips are just tucked under the display. Let me shine a light down the side of this. Can I see anything? Yeah, I can just see one chip. The fact it's got one chip suggests it's this little microcontroller. It's just in there. The other one probably doubles up with the microcontroller and display driver, but this one is just being cheap, which suggests it might run the display dimmer. Is the display going to look any worse for that? Hold on, let me just slap the power supply onto these connections here. Willy-nilly. Display looks okay. Don't know what it's set for because it's gone into... Oh, it's set for 10 degrees Celsius with a differential of 3. That is the default setting, I think. So that's going into compressor mode. So that kind of suggests these are originally come out kind of set for refrigerator type applications. Right, tell you what, I'm going to take a picture of one of the circuit boards and do a little bit of exploration, and I will then let you know what I find. One moment, please. Okay, let's explore. Let's start with the mains voltage version. So the supply comes in here and it goes straight to the bridge rectifier. Then a smoothing capacitor rated about 4.7 microfarad, 400 volts, I think it is, which is a Changzin capacitor. Yeah, about that. It's hidden. Oh, 4.7 microfarad, 450 volt extra 5G death beams with this one. That supply, the positive then goes to the coil of the transformer, the primary, and the negative gets switched with this switching chip. There's a little snubber network across it, just the usual setup. There's an auxiliary winding used on the transformer, and this is how they've actually done a double jump across this in the low voltage version. There's an auxiliary winding which feeds via this diode to this capacitor. And that is also trickle charged at the beginning through these two 1.5 megohm resistors, so about 3 megohm, which slowly charge this capacitor up until it's ready. Once it reaches a certain voltage threshold, it starts this chip running and then the circuit powers itself. So there's that little initial time delay before it starts. It's also, if the capacitors fail, it'll also be the bit that makes it pulse on and off. The display will flash probably. Other things that happen in this, the feedback winding that also powers that chip is also used for a sense via a couple of resistors here. There's a little capacitor, probably for internal reference. There's a sense resistor, 3 ohms, but they've got a position for 2. As usual, it's fundamentally the standard switchboard power supply. The output goes via a single Schottky diode over to charge this capacitor up to probably about 12 volts for the relays, and it will power them directly. Then there's a 5 volt voltage regulator and its little 5 volt smoothing capacitor. The relays are switched by these two transistors, and there's a back EMF protection diode across the coil of each to protect the transistor from the spike caused by the collapsing magnetic field in the coil. These are longle. It's like songle, but it's longer because it's longle as opposed to songle. That's like a clone. That's a clone of a fairly standard relay. I'm not confident about these. The sensor over here with its connections directly in the vicinity of direct reference to the mains, basically speaking within millimeter or so of the rectified mains, it goes over to this little cluster of resistors over here, and the arrangement is 5 volts, goes through the 10K negative temperature coefficient temperature sensor, and then it forms a potential divider with another 10K resistor with a capacitor across it for filtering, and then via a 1K up to the microcontroller itself. That's repeated in another unit. There are more pads here because it's designed for multiple functions. I'm wondering if the two sensors here are maybe for an alternative unit where it's got heating, defrost heating and refrigeration, and it's maybe got like cavity temperature and evaporator temperature, or air on, air off. Not really sure. It looks a very universal unit. I think this thing over here may have been a buzzer, because it does mention an alarm sounder. If you disconnect the probe, or if it's short-circuited or open-circuited, it will display error on the display. Double E, I think it is, and potentially it would have sound alarm, but the alarm would also sound if the temperature exceeded a ridiculous level. That's more or less it for the mains voltage one. Let's take a look at the lower voltage one with what look like better quality relays. They're bigger. Not sure about the brand. Shanghai. You can see all the component layout as if it was the other one, but instead of actually having the mains voltage circuitry, it's got the low voltage coming in, it's going through the spread rectifier, and then it goes, because that would normally go to positive and negative, and because the primary winder would normally have the positive, and the bootstrap winder would normally have negative, they've just taken a link from those over to the other side. One of those then provides the negative. The other one goes through this diode, which is the same diode used on the mains voltage version. It's a Schottky diode, and there's probably the same capacitor used. They have left off the 5 volt capacitor because they decided to leave that off for some reason. I'm not really sure why they did that. It seems a bit of an odd thing to do. Oddly, they've got the same arrangement with the 1K resistor in series with the base of each of these two transistors that's switching the relays, and they've got the same diodes. But they've got 2 sets of thermistor components here and 2 links. The links just go nowhere. It's like they don't really know what they're doing in this case. Or it's almost as if this version with the links, if the links are in, they can leave these transistors off and it's switched from the unit itself. It's very odd. I'm not really sure. I've not seen one like that. The other thermistor, these two resistors and this capacitor go to that unpopulated position. I wonder if they've just put them in because they didn't know any better. It's very odd. But that's the main difference, is they've just left off the power supply and put two links across. I wouldn't use an AC transformer for this. I'd use a 12 volt DC supply. Because if you do use 12 volt AC, it will end up a quite high voltage. It will be, well, let's work it out. 12 volt AC would peak at 12 times 1.41. It'd peak around about 17 volts, and minus the diodes here and this Schottky, it's not going to drop it down much, so it's going to potentially overvolt the coils a wee bit, make them last less time, get hot. So I'd recommend running it on a 12 volt DC supply. That would also let you connect, let me just grab something here. In the case of this much more opulent and more expensive temperature controller, what brand? What brand is this? sfyb.com. In the case of this one, it does use a little external transformer, a traditional one to power the module, but for switching loads, it actually has an external relay, and all the wires are just sort of like blobbed in with hot melt glue. You can't really change the thermistor in this one, which is a bit disappointing. Bigger thermistor arrangement and thicker cable, but it has a couple of cables that go into the transformer. And then it's got these two spade connectors go into the relay. And I'd recommend using a 12 volt relay and a 12 volt DC supply with these things, and a 12 volt module. 12 volt all the way. It's a little bit more complex wiring it up, but it's going to last a lot longer. And that is about it. Not really much else to say. Not happy at the separation on the mains to the thermistor. I don't know if that's a huge problem or not. It means that the thermistor cable, I mean, it's not directly connected to the mains, but the vicinity of that could cause problems with humidity and tracking and stuff like that, I suppose, really. Although nothing should really be referenced to ground. What the display's like, are they the same displays throughout? What about the other one? Yeah, very cloney, very strange. It's just like copies of copies of copies. So there we have it. That's the classic, going to have to look at the front of this, STC-1000 temperature controller that can both cool and heat. I mean, there's a lot, you're getting a lot for your money. But as I say, I'd recommend against the mains voltage one, and I'd recommend against switching high loads through these relays. I'd recommend, if you've got a serious application, 12 volt, and using these relays to then switch the coil of a beefier, chunkier relay, and that means all the wear is moved to the outer relay, and it means that it's a cheaper, easier fix. Although having said that, these are about £10 each, so it's not that dramatic. It also avoids any awkwardness of these things burning up inside, as can sometimes happen. So there we go. Interesting. It was certainly well worth exploring inside. I'm always tempted to see if I can find some that don't look the same, just to see what sort of variations there are. But I'll also be getting some other temperature modules just to see how they sort of vary and in quality and if they're just rip-offs again. But interesting stuff. Really interesting to look at.